In this example, we have a block of mass 6 kilograms is hung from rope that is wrapped around frictionless pulley having a shape of cylindrical shell. This block is accelerating downward with the acceleration of 5 meters per second squared, and the objective is to find the mass of this pulley. We have two objects, one is rotating and one moving in straight line. So the one that is rotating, which is the pulley, we are going to use the condition of rotation, which is the sum of the torques equals to the moment of inertia of the rotating object times its angular acceleration. Now for the object that is moving linearly, we are going to use the sum of forces applied on this object equals to the mass times acceleration. Let's start with this object. We do the free body diagram. It will be the mass times gravity. This is the force, which is the weight. And there is a pulley pulling upward. We call it T. The object will be moving downward. The acceleration and mg are in the same direction because the object will be accelerating downward. The mg and acceleration will be in the same direction, will be positive, and the tension against in this motion. So what we will have, the sigma of these forces equals mg minus tension equals ma. I repeat, we said mg is in the same direction of motion, which is the direction of acceleration, are positive. The tension is against in the motion, will be negative. So the sum of these forces equals the mass times acceleration. Now I put this equation by itself. We have mg minus tension equals ma, and I keep it by itself. Now I go to the pulley. How many forces that are rotating this pulley? In this case, we will have just the torque provided by the tension, which is the moment of inertia of the pulley, times its angular acceleration. The torque of tension will be just this tension times the distance, the shortest distance from the rotation point to where is tension is this radius. Remember, magnitude of torque is the force times the shortest distance. This d perpendicular means is the shortest distance to the rotation point. Okay, so the shortest distance to the rotation point is r. In this case, it will be the moment of inertia times angular acceleration. Now, what we know about the moment of inertia of the cylinder, we said is the mass times r squared divided by 2. This cylinder is a shell, but remember this shell thickness is very small thickness. There is no outside radius. The only radius we have is r. So let's say if the shell looks like that, then the moment of inertia, this one I call it r1, and this one I call it r2. The moment of inertia of this shell, cylindrical shell, will be 1/2 times the mass times r1 squared plus r2 squared. But for now, we have just one radius because it's not too thick, okay? We replace the moment of inertia, the mass of the pulley, times the radius squared divided by 2 times the angular acceleration. Remember the tangential acceleration A, let me put it here, the tangential acceleration, this acceleration, which is this one that makes the object go down, it will be just the radius times angular acceleration. So T times R, put it here back, will be the mass of the pulley times the square of the distance times angular acceleration divided by 2. I have power here too. I have 1 R vanishes. It will be just M times r times alpha, because we have one r left. We cancel one here, we have one left. R times alpha will be just a tangential acceleration, or just we call it acceleration. This is divided by 2. Okay, so what do you know here? T equals the mass times acceleration divided by 2. Now what I will do, I will just replace this here, and then I will look for the mass of my object. So we go replace the tension with m times a over 2 in here. We have mg minus m times a divided by 2 equals to the mass of the block times acceleration. So we are looking for the mass. If I move this term to this side, it becomes positive. If I move this one to this side, it becomes negative. So we have mg minus ma equals the mass of the pulley times acceleration divided by 2. M times gravity minus acceleration of the block equals m times a over 2. Okay, so if I multiply each side by 2 and divide by acceleration, what we will have? 2 divided by a times the mass times gravity minus a equals to the mass of the pulley. Now we just replace the values of the mass and the acceleration of gravity and the acceleration of the block. We said the mass of pulley will be 11.52 kilograms. Thank you.